Okay, we're going to do a section of chapter 11 here in the middle of our chapter 10 section, and that's just because it fits in so nicely and cohesively with chapter 10. So let's just go ahead and get started. This is what we on the calendar is marked as the arc length and area sectors. So we're combining two sections of chapter 11 that we're actually going to skip later on in the month because one of the sections just deals with the circumference and area of a circle, which you already should know. The circumference is the distance around the circle, which is the 2 pi r, or you can use this pi d, which is a little easier in my opinion just because it's easier to remember, the circumference being pi d. It's not to be confused, which some of you may have done on the last quiz, with the area of a circle. So the area of a circle is equal to pi r squared, which we are going to use here in a little bit. Okay, so we need to keep these two straight. So circumference is pi d or 2 pi r, either way, and then your area is pi r squared. Okay, now if we're dealing with a bicycle wheel that has a 26-inch diameter, how do I find the circumference? Well, we just stated that circumference is equal to pi d. And the main reason I'm using d here is because it gives me the diameter. So if I put the diameter in terms of pi, which is acceptable from time to time depending on what the question's asking, you could put diameter being 26 pi. And sometimes this solution will be what you use, and that's what you would call in terms of pi. If I kept the answer in terms of pi, it would be 26 pi. But if I went ahead and multiplied that out, I would do 26 times pi, and I would get 81, 81. And again, if you do 3.1 approximated, but I didn't approximate, so it's going to be 81.6814. And so that would be your circumference right there. Okay? Now the other thing I want to do is if I change that 81.68 inches to feet, because we're going to talk about that. We're going to need that here in a second when we talk about this question down here. If I want to change that to feet, I would take my 81.68 and divide it by 12. And what you're going to find out is that in feet, your circumference is 6.81 feet. Okay? So again, I'm just converting this for the practical purposes of our next question. Okay, so if I'm riding this bicycle with a 26-inch wheel diameter, then how many revolutions are going to be in a mile on this particular bicycle? Well, the first thing we can get to remember is that a mile is 5,280 feet. Okay, if you didn't know that, shame on you. It's just kind of a general trivia question. But you know it's 5,280 feet. So if it's 5,280 feet, and you know that every revolution is the circumference, so every revolution takes 6.81 feet, then all you would have to do is take that mile, 5,280, and divide it by 6.81 feet to see how many times it would how many times the bike tire would actually rotate in a mile. And what you're going to find out is that bike tire is going to rotate 775.33 times in 1 mile. Kind of an interesting use of circumference to figure out how many times it revolves in 1 mile. All right, let's keep moving. if we're talking about arc length, which is our new thing, because again, circumference and area we should already be familiar with, but if we're talking about arc length by definition is a fraction or a part of the circumference. So if we look at this in terms of degrees, because we measure the degrees around a circle, and the degrees around a circle is 360 degrees. And if I take 90 degrees, that's just part of that 360, you would say it'd be 1/4, that arc length, if I just took 90 degrees, is 1/4 of the circle. And you can set it up as a proportion. Likewise, if I take 45 of the 360, okay, all I got to do is simply reduce that. So 45 divided by 360. If I reduce that down, you're going to reduce that to 1/8. So when you're talking about 1/4 of the circle, that's 1/4 of the circumference. Because here you have degrees. Okay. And then here you have 1/4 of the circumference, or in this case over here, 1/8 of the circumference. So, if we're looking for arc length, we can use a formula. It's a little different from what's in your textbook. We can use, wait, let me go back 1 second, sorry. A proportion, and it's not a formula. Okay, so it's a little different than what's in your book, because in your book it shows the actual formula, but we can use a proportion, which basically is degrees over 360, because that's an entire circle. So the degrees of this arc over 360 equals the arc length over your circumference, which is pi d. Okay, so if you need to make a note of that, make a note that this is circumference. Okay, and again, I know it's hard to read, and I apologize, but I just wanted to make it smaller. So here's your formula, or your proportion that you can use in order to find the arc length. Again, it gives you a formula in your textbook, but this is better to set it up this way, because if you're ever looking for something other than the arc length, like maybe you're looking for the measure in degrees of the arc, and it's giving you the arc length, you can plug it in any part of this proportion and solve. So if we go over here to this problem here, we would set it up like this right here. It's giving us 40 degrees is our arc measure, right? And that's because our central angle here is 40 degrees out of 360 degrees is equal to, now in this case, this problem is not giving, it's giving us the arc length, which is 4.19, and we need to find the diameter, or we can find the radius. Obviously we know what pi is. So now we can use that to solve, and so as we solve this, we would simply cross multiply, and so you would see where we would do 360 times 4.19 is equal to 40 pi d. You go ahead and continue to solve that, and you could also reduce that 40 over 360. You could reduce it down if you wanted to, and then cross multiply. That would work just as well. But for this example purposes, we're going to go ahead and use the entire number. So then you would end up with 1,508.4 is equal to 40 times pi d. Continue to solve for d, so divide both sides by 40 pi. You're going to end up with 37.71 pi is equal to d. And then if you wanted to, sorry, I wrote that wrong, 37.71 over 37.71 over pi is equal to d, and then you divide that by our pi function, and we end up with a diameter equal to 12, approximately 12. And again, depending on what you're using to round, if you're using 3.14, if you're using the pi button, you could end up with 12.0035 or something to that extent. But that helped us find our diameter. And again, the reason that we wanted to do that, I wanted to show you that example, is because rather than using the arc length formula that's in the textbook, you can just set it up as a proportion as I did right here. And that way you can solve for anything that's missing, any unknown value. And most oftentimes students like to use proportions versus formulas anyways, and they're easier to remember. So think about this. Here's your degrees. Here are your degrees. Here are your lengths. Okay, and again, degrees, partial degree over the entire circle is equal to the arc length over the circumference. Because the circumference, again, if you just remember, is just the length around the circle. Okay? All right, let's keep moving. If we're talking about a sector now, a sector of a circle, when we talk about sectors, we're talking about individual parts of something. You know, if we talk about a sector of a city, like if we're doing a manhunt, hey, what sector of the city are we in? We're not talking about the entire city, we're talking about just a portion of the city. So the same thing goes for like a sector of a circle. If we're talking about the sector of a circle, it's just a portion of the circle. Okay, so it's defined by the region bounded by two radii and an arc. So if you look down here in this example, here's a radii, here's a radii, here's an arc. So everything in this shaded area here is my sector. Okay? So again, sector area, okay, so that's the definition of a sector. Sector area is everything in here, right? That's actually calculating that. That's the fraction of a circle, or it's a fraction of the area of a circle. So this is where your pi r squared comes into play. Because if you look here at our proportion for sector area, that's right here. It's very similar to finding our arc length. We take the degree measure, that portion of the degree, so in this case we'd take that 90 degrees, put it over the entire 360 degrees, just like in the arc length. But this time we're going to take the sector area, which in this case is the unknown, and we're going to divide it by the area of a circle. And that's where that pi r squared comes from. And then we just solve for x. Okay? So if we continue to work this problem out here, we could cross multiply and have 360x is equal to 90 times pi times our radius squared. And then we're going to have 360x, and I'm just going through every step so we don't miss anything, equals 90 times 16 times pi. Continue to work that out. We have 360x is equal to 90 times 16, which is 1440 pi. Then I can divide everything by 360. 1440 divided by 360 gives us x is equal to 4 pi, and sometimes that'll be an acceptable solution if it asks you in terms of pi. So our sector area would be 4 pi. If I wanted to go ahead and calculate that out, I would just multiply, of course, by my pi function there, and I would end up with something if I rounded to 3.1, I'd end up with something like 12 point, x is equal to 12.56. And again, that's going to have a little bit of wiggle room depending on if you use 3.14 or if you use the pi button. I always like to use the pi button because it gives me more of an exact answer, as close as it can. And that would be pretty much it. And that's how you find sector areas. So, pretty simple stuff. I don't think that we'll have any issues with this. If you have any questions, as always, please come see me after school at PASS or ask me during class. Other than that, you guys have a great day.